A long solenoid of radius 2 cm has 100 turns per centimeter and carries a current of 5 ampere. And there is another coil of radius 1 cm that is having 100 turns and a total resistance of 20 ohm that is placed coaxially with solenoid. Now what is happening is, let us say this is my solenoid and that is wounded around by the wire, and there is another coil whose axis is same to that of solenoid. Now what happens is that the magnetic field inside the solenoid will completely pass through this coil. So what we'll be doing is we'll calculate the magnetic field at the center of the solenoid, that is B, that is given by mu naught N into I. So substituting all the values, the value of N is given to me as 100 turns per centimeter and current is 5 ampere. So magnetic field is mu naught into 100. Now this N is per centimeter, we have to convert it into per meter so that every unit is in SI. So we'll multiply it by 100, we get 10 to the power 4 turns per meter. So N is this into current, that is 5. This is the magnetic field at the center or at the axis of the solenoid. The next thing we'll be doing is we'll calculate the flux that is passing through the coil, because now we have the magnetic field that is passing through the inner coil. So the flux that is passing through the coil will be given by number of turns of the coil into magnetic field into area of the coil. So the value of N2, that is the number of turns in coil, is given as 100. The magnetic field passing through the coil is also given, and that we calculated above, that is mu naught into 10 to the power 4 into 5 into area of the coil. We have a coil of radius 1 centimeter, so it will be pi r square, where radius is 0.01 into 0.01. This is the flux passing through the coil. Now if the current in the solenoid is reverse in direction, what happened will that the magnetic field earlier was in this direction and then the direction will change to this. So the change in flux will go like phi 2 minus phi 1. Now there is just change in the direction but no change in the magnitude. So let final flux be in this direction and we assume it to be the positive direction. So phi 2 will be minus and phi 1 will be equal to phi 2 but with a negative sign because the direction is reverse. So phi 1 can be written as minus of phi 2. This is equal to 2 times of phi 2, that is 2 times of 100 into mu naught into 10 to the power 4 into 5 pi 0.01 whole square. Now calculating the EMF that is induced in the coil, given by minus of d phi by dt. Now let's talk only about the magnitude. We have d phi, that is 2 into 100 into mu naught into 10 to the power 4 into 5 pi 0.01 whole square divided by dt. Now we have the EMF, we have the resistance of the coil, so we can calculate the current that is passing through the coil, which is given by I is equal to E by R. So EMF is 2 into 100 into mu naught into 10 to the power 4 into 5 into pi into 0.01 whole square divided by 20 into dt. dq by dt, this is given by 2 into 100 into mu naught into 10 to the power 4 into 5 into pi into 0.01 whole square divided by 20 into dt. So this dt and this dt will go off. So we have the charge that is flown through the coil. So on solving this equation, we get the value of q as 2 into 10 to the power minus 4 coulomb. That is the answer.